Welcome to the project demonstration of detection of power grid synchronization failure on sensing frequency and voltage. In this project we are using PIC microcontroller and comparator board, LCD display, relay and AC bulb rectifier. So we are providing, and also we are using two parts. One is for the voltage and another is for the frequency. And we are providing a power supply through this power cable. It takes 230 volts of power supply that will be given to this rectifier, and also the 230 volts power supply parallelly given to this AC bulb. And also here we can see relay is connected between the bulb and 230 volts AC power supply. So the neutral wire commonly is connected to this bulb and the phase wire will be connected to this relay. Whenever the relay gets switched on, then automatically this bulb will be get switched on. So here we can see there was a using this 230 volts power supply, we are splitting the 230 volts power supply to this rectifier and also bulb. So here we can see the 230 volts power supply will be taken by this rectifier and will step down up to 5 volts and it will convert also 5 volts. So it is taking 230 volts AC and it will giving the output of 5 volts DC. That 5 volts DC will be utilized by this PIC microcontroller, because PIC microcontroller, LCD and the relay, these parts are works on the 5 volts of power supply only, and also this comparator board also works on the 5 volts of power supply only. So we are giving the power supply to these components using this PIC microcontroller board only. So the 5 volts will be given to this PIC microcontroller, then PIC microcontroller will divide the 5 volts to these components. And also here we can see frequency part is connected to the comparator board and it will compare the frequency and it will change the frequency. That frequency will be given to this PIC microcontroller, and the voltage part will be given to this PIC microcontroller. It will change the voltage values. So one doubt will be raised in our mind that this part also have to give the PIC microcontroller, but why we are giving the frequency part is given to this comparator board? Because this PIC microcontroller will compare the only single variation of the voltage only, so it doesn't compare two variations. That's why we are giving the, to calculate the variations of this frequency, we are using a comparator board. Now we are giving the power supply now. So this is the normal position. So here we can see 230 volts of power supply and frequency is 51. If it is more than 51 or 52, it will show as a high frequency and this bulb will be get switched off automatically. For the frequency variation we are using this part. So this is the high frequency, so that's why this bulb will get switched off. So we need to initialize this part as a 50 only. Now it is not showing any high frequency. After that we need to reset this button. So this system will be starts. If it is in a less frequency, so we can see low frequency and bulb will be get switched off. So we need to initialize the frequency levels. Now we are varying the voltage using this part. So this is a high voltage, that's why bulb will get switched off. Now I am giving a low voltage, so up to 230 or to 235 it is a normal voltage. If it is more than 230 or 235 volts, it will show consider as a high voltage. Now we need to reset this one. Now I am decreasing the voltage. Now you can see if it is less than 210, it will consider as a low voltage, then automatically bulb will be get switched off, and we need to maintain nearly 220 230, then only we need to reset this button. So coming to the practical world, as a practical real-time project, there will be a man who will be monitor these values, and also after the monitoring the values he will be stabilize the voltage and frequency levels in the real-time projects. So in this way this project will be works. Thanks for the watching.